I hope you enjoy the following class. Do realize all of these video classes are based on what I teach at Silicon Dojo here in Asheville, North Carolina. These are free to the end user, hands-on technology classes where basically you just sign up, you show up, and you get to learn technology. I will remind you that free to the end user is not actually free. All of this stuff costs me a shocking amount of money. So if you would like to support the educational programs that I am creating, the education that I deliver, please think about clicking on the donor box link down below and throwing a couple of dollars in for the cause. I hope you enjoy this class, and more importantly, I hope to see you at Silicon Dojo sometime in the future. Welcome back. As you know, I am Eli the Computer Guy, and in today's class, we're going to be using MAC addresses, Media Access Control Addresses, to determine the vendors of the different devices that are on our network using a REST API and Python. So MAC addresses, Media Access Control Addresses, can be very useful for you and very interesting for you as an IT administrator. So MAC addresses reside on the layer 2 of the OSI model. So whenever you're dealing with a networking protocol such as TCP/IP, so IPv4 or IPv6, you're dealing with layer 3 routable networking. So that's where you actually are able to configure IP addresses. You're able to have separate LANs, they have routers to connect to other LANs, and basically you're able to have multi-layer networks. Well, you can actually have layer 2 networks, and layer 2 networks are basically where you just connect the computers into a switch like this, and then they're able to communicate with each other. So back in the days when I got my MCSE back in 2000, I actually had to learn something like 10 different protocols, right? So nowadays, you all go out and you learn IPv4, and that's it, right? Back in the day, I had to learn about IPv4 and what NetBEUI and IPX/SPX and NW-Link and AppleTalk. There's a whole bunch of different protocols out there. Now, but one of the interesting things back then is we actually used layer 2 protocols. And the great thing about layer 2 protocols is that they did not have to be configured. Basically, you could plug all of your computers into a switch, and then voila, they could simply see each other. You didn't have to deal with subnet masks and scopes and all of that kind of stuff. Well, the thing is, again, remember in the computer world, nothing happens magically. There actually has to be a reason things are able to happen. And the reason those computers were able to communicate with each other is that they had MAC addresses, Media Access Control Addresses. So these are hexadecimal addresses that are hard-coded into the networking ports of your computer to give them an identity. You know how you hear some of the conspiracy theorists out there, and they talk about how the new world order is going to try to put a social security number onto everybody's computers? Like, you hear about this every once in a while where they're like, yeah, it's horrible. They're trying to create a unique identifier for every computer so they can track you. And do you know what I say to that? That's built into the computer. It's called a MAC address. It's literally been there for 40 or 50 years. What? Right? And that's the thing, is basically, think of the MAC address almost like a social security number. Again, it's supposed to be globally unique. And when I say globally unique, I don't mean domain unique. I don't mean LAN unique. I mean like in the entire world, it's supposed to be unique. And basically, it is an identifier for the computer so that switches are able to identify the different computers on the network and then be able to send data to the appropriate computer, right? What's interesting is you may have heard of ARP, Address Resolution Protocol. So when you're using TCP/IP version 4, right, IP version 4 is at the layer 3 of the OSI model. When things using TCP/IP4 have to be able to communicate with each other, there's something called ARP, Address Resolution Protocol, that actually resolves IP addresses to the MAC addresses, again, so that the computers are able to communicate. So the important thing to understand here is every single computer that's connected to at least an IPv4, an Ethernet type network, Wi-Fi, whatever, will have one of these MAC addresses. And again, essentially think of it as a social security number, because whenever there's any kind of network communication, the network has to be able to identify each computer so that it knows where to send and receive packets from. Now, the interesting thing with this MAC address is, again, one of the questions you have to ask, because nothing magically happens, is, well, how do we get a globally unique address, a globally unique identifier. If you have 10,000 different manufacturers out there, all producing different networking equipment, they're all spitting out, even if they're spitting out completely random MAC addresses, at some point you're going to get some kind of weird duplication, and then you're going to run into really bad problems. So how these MAC addresses are actually created is the first part of the MAC address is actually an identifier for the vendor, for Apple, for Raspberry Pi, basically whoever produced that piece of networking equipment. And the second part of the MAC address is then essentially a serial number for the device itself. So, Apple and Raspberry Pi and Dell and all of those, they'll have their identifier. And then after that will be a serial number. And so that should give you essentially a globally unique address. Well, what's interesting about this then, right, is if we know the identifiers for the first part of the MAC address and what vendors they associate with. Basically, if we're able to get computers' MAC addresses, we then should be able to figure out what vendor produced that particular computer. And again, use that for whatever purposes we want to use it for, right? So again, if we're going to do network scanning, that type of thing, we can go out, we can do a network scan, we can get the MAC addresses from the computers on the network, we can then try to associate them with vendors, and then we have a better idea of the environment that we're dealing with. So today what we're going to be doing is we're going to be using a REST API from a company called MacVendorLookup.com. Basically what we're going to be doing is we're going to be taking MAC addresses that our computer is able to detect using Python. We're going to feed those MAC addresses to their API. We're then going to get a response back with who that vendor is, and then that is something that we might be able to find useful going into the future. Okay, so let's do a bit of a demonstration before we dive into the code and really explain how all this stuff works. So we have 3 scripts that we're going to be dealing with today. This first one is where we simply feed in a MAC address. We feed that to the REST API at MacVendorLookup.com, and we simply print out the company name that's associated with that MAC address. So if I hit the go button here, we can see for the MAC address, DC8632 blah, blah, blah. That is for the Raspberry Pi Trading Ltd. So we know this MAC address is associated with a Raspberry Pi. So that's pretty cool. The next script that we're going to do is that we're actually going to dump our ARP tables. So the ARP is Address Resolution Protocol. So again, whenever you have a layer 3 piece of networking equipment that has to communicate over a switch, you're going to have to associate the IP address, the TCP IP4 address, with that MAC address. So everything is able to communicate. That's what Address Resolution Protocol is. It's resolving MAC addresses to IP addresses. Basically, with this, every computer that your computer has seen, it will then spit out with the IP address and the MAC address for all of the computers that your computer has seen. Now, if your computer hasn't seen it, that's its own deal. So this isn't doing network scanning. This is basically just what your computer has seen. So if your computer has communicated with a printer, if a computer on the network has sent out a broadcast, right? If there's any reason why your computer would have seen it, this will come out. And so basically with this, it's going to print out all of the values in the ARP table. And then from that, we are then going to get the vendors for all of those values. So we're going to get the IP address, we're going to get the MAC address, and then we are going to get the vendor. If I hit go, so we're going to hit go here. And okay, record 10.0.1.1, we get the MAC address, we get Apple. 10.0.1.2, MAC address, HP. 10.0.1.4, MAC address, don't know what the vendor is there. .13, MAC address, Raspberry Pi. .34, or 35, MAC address, Raspberry Pi, and then these are just broadcast domains and that type of thing down here, not to worry about it. Now, the interesting thing with this, again, remember when I talk about the MAC addresses, the media access control addresses, there is a different MAC address for every NIC, network interface card. So this Raspberry Pi is hardwired connected into my router back there, and it's also wirelessly connected to the router back there. So one of these MAC addresses is for the hardwired connection, connection. One of these network MAC addresses is for the wireless connection. But basically, again, this kind of shows you how you can go and you can see the IP addresses, the MAC addresses, and then try to associate it with the vendor. So we're at 10.0.1.1. Okay, I know that's some kind of Apple device there. Again, HP, that's most likely a printer. And this can give you a better idea, again, if you're walking into a new network, trying to figure out what the hell is going on. The final thing, right? So if we go here, this particular script is where we can ping. So when we do the ARP, right? When we look at that address resolution protocol table, that ARP table that we're using in the previous script, that will only show us the computers that your computer has already seen for whatever reason, already printed, already shared a file, already received an email from, something like that. If your computer has not communicated with that other computer, another computer on the network, for whatever reason, it will not show up in that ARP table, and so you will not be able to see what the MAC address is or what the vendor is. So with this particular script, what this allows us to do is it allows us to ask for an IP address, and then with that IP, once we have that IP address, we can get the MAC address, and then once we have the MAC address, we can ask what the vendor is, right? So if I know that there's a computer out there at 10.0.1.100, it doesn't show up in this ARP table, but I want to know what the MAC address is and possibly what the vendor is, we can use this particular script. So when I run this, so we have the input, so it's asking us for an input here. So I'm going to do 10.0.1.3. So this was a computer that we did not see in the list. I'm now going to hit enter. It is now currently pinging 10.0.1.3, and hopefully, there we go. It gives us the MAC address of 10.0.1.3, and it says the vendor of that MAC address is an Apple computer, right? So these are the 3 different scripts that we're going to be going through today. And again, it's a pretty useful educational tool to show you a little bit more about how Ethernet networking actually works. Again, about how to do things like deal with REST APIs. And then also, we're going to be using regex today, which is oh so exciting. So first things first, here is the website for macvendorlookup.com. So this is a free REST API that you can use. Now again, when I'm showing you these REST APIs, I will almost always be showing you either the free ones or the incredibly inexpensive ones, because again, this is an educational environment and I'm trying to teach you the concept. I'm not the most worried about if this is the most accurate data in the world. But do realize, again, whenever I'm showing you these APIs and I'm showing you the free version, most likely it's free because, you kind of sort of get what you pay for. Not that this isn't good, this is fine, but it may not be one of the best ones out there. So again, just one of those things to be thinking about with APIs is, hey, paying $10 or $20 or $100 a month versus getting the service for free, there might be a value proposition there. Again, with these MAC addresses, essentially all we're doing is we're doing a query, essentially a select query against a database and saying, hey, do you have this front of a MAC address in the database? If so, what does it associate with? And so again, the quality of the database will really matter at the end of the day if you're going to be using this in some kind of production environment. Now with this, just to kind of show you what's going on, I can simply paste in a MAC address, so 5CE91E86A72C, and this will show us here MAC address details. It comes from Apple at 1 infinity loop, and there's a range for the MAC addresses here, right? So basically, this is the type of information you can get a MAC address. And again, if you don't want to go through this whole API thing, you can just actually copy and paste the MAC address here, and it will tell you the vendor. Again, what we're interested in, though, is REST APIs. So for the REST API, you go to macvendorlookup.com/API/v2, and then whatever the MAC address is. When you do that, essentially dynamically, you get a very ugly web page that's created for you, and that very ugly web page gives you JSON, right? So it gives you a start hex, end hex, start, all kinds of stuff. The important thing you're looking for is company. So company for this MAC address is Raspberry Pi Trading Company. The address for that company is Maurice Wilkes Building, Cowley Road, Cambridge, CB4, 0DS, Great Britain, so on and so forth, right? So this is what we get. So this is the website itself, and this is going to be the REST API that we're going to be interacting with. Now, for this API, the only real quirk that I found from a coding standpoint is they do have rate limiting. And when you're doing loops, rate limiting can really screw you up. So they limit you to one query every second. So if you do more than one query per second, they will actually block you. If you continue to hammer the hell out of their service, the service will start getting worse and worse and worse for you. Why that's a problem is when we deal with that ARP table, right? That ARP table is, as I showed you, it returns like 10 different values, and Python is just going to rip through those values as fast as possible. So if you basically download the ARP table, you then go do a 4x loop through that ARP table to resolve vendors to MAC addresses. It's going to go as fast as possible, and basically you are then going to go over one request per second, which means their service is going to block you. You then hit the go button again because, well, something happened. What's going on? And then their service is going to get more and more and more angry with you. And then everything kind of might go to hell. So really, the only problem at all with this particular REST API is it has a rate limit of one request per second. You'll notice when we go through the code, that second script that I showed you, at the end, it's actually going to delay by 2 seconds. One of the reasons that script takes as long as it does is because every time it loops through to resolve a MAC address to a vendor, it waits for 2 seconds, waits for 2 seconds, waits for 2 seconds, waits for 2 seconds. So that's one of the reasons why that script takes a long time. Now, again, I've got 6 or 7 devices on this particular network. Oh no, it takes 14 seconds for it to finish. That's not a big deal. Something to think about, right? You got a big network. You have a network with 500 devices on it. 500, multiply by 2 seconds, then comes out to 1,000 seconds, which, I don't know, what is that? 60 seconds, 10 minutes. It might take like 20 minutes for that script to finish. And again, this is the kind of thing that you have to think about whenever you're developing these apps. So anyways, this is the website and this is the API. And again, the only real issue I see is with the rate limiting. So let's take a look at the first script. And the first script should be pretty simple for you if you've been following along with the REST APIs. And if you haven't been following along with the REST APIs, by the end of this, it should seem pretty simple because it is. Basically, the first thing we're going to do in Python is we're going to import the request module. The request module is what actually allows us to go out to a URL, bring down the values from that web page, and turn that into a variable value. So we just import requests. Then we're going to have MAC_text. So this is the MAC address that we're looking for. So this is 6, 1, 2, 3, 4, 5, 6. So it's hexadecimal. So A through F, 0 through 9, uppercase A through F, lowercase a through F, and it's either single or double digits here. And so basically this is what you get with the MAC address. The URL is then going to equal, we're going to use an F string so we can dump in that MAC text in, and it's just macvendorlookup.com API, remember the V2, and then we dump in that MAC text. So the vendor, so when we do this, so vendor is going to equal request.get URL. So we're going to get everything from this URL that we entered, and then we're going to save it as a JSON value. So if we don't do this, we're not going to be able to interact with it as a JSON format. Then we're going to do vendor_text equals vendor at index 0 company. So if we take a look at this, right? So when we take a look at this REST API, so we open with a bracket and we close with a bracket. We notice there's no commas. So this is all in the 0 index. So when this comes in, this is in the 0 index. So we go to 0 index, and then within 0 index, we go to company. So 0 company will print out Raspberry Pi or whatever that vendor is, right? So vendor at the 0 index at company, and then we're simply going to print out vendor_text. And when we do that, we're simply going to get Raspberry Pi, a trading LTE. So that is the vendor for that particular MAC address. So this is pretty simple. Oh boy. So the last one was pretty simple. This one is going to get us into regex, regular expressions. If you take a look at this particular script and your mind kind of melts a little bit, don't worry. Everybody feels that way. I don't know what it is, but in the coding world, in the programming world, everybody hates regex. Everybody, the noobs hate regex, the old timers hate regex. Regex just sucks. So anyways, I'm going to try to explain this to you. Hopefully you'll be able to follow along. If not, don't worry. You'll learn regex as it goes along. Anyways, so with this particular one, to start off with, I have commented out the bottom of this is where we're actually doing the resolving and all that kind of thing, because I want to take a look at the command itself. So let me uncomment this out. So when you're looking at the script on EliTheComputerGuy.com or wherever it's stored, you'll notice the print is commented out for response, and then everything else is here. I just want to show you what this response looks like so that you can then start to understand how we're parsing this response. So we're going to import a subprocess. So subprocess is what allows us to send commands directly to the operating system and get the result from those commands. Requests, again, to go out to a URL, import RE. That's to import the regular expressions. I'm sorry. I'm sorry. We got to do it. We got to do it. And then from time, import sleep. And we're going to be doing this because we're going to be delaying the loop for 2 seconds every time it goes through. So we do not hit the rate limit and everything kind of goes to hell. So anyways, the command that we're going to be using is command equals arp space -a. So this is basically dumping the arp table with all of the values. Response equals subprocess check output for command. So we're going to run arp space -a for command. Shell equals true. So basically it goes to the shell, and then we're going to print out what the response is. So when we do this, it'll take a second. Dun, 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 dun. Okay, so this is what the response is going to look like. 10.0.1.1 at this MAC address on Ethernet 0 IF scope. 10.0.1.2 at this MAC address, so on and forth. 10.0.1.3 at this MAC address, all of these different things here. So basically these are on different lines. You'll see that /n question mark. So basically /n is a next line. So let me just show you this. Let's see, we can just go to we can just go directly to the terminal. And so just to show you here, let me just do clear. I can do arp space A. And so this is actually on the terminal itself. And again, 10.0.1.1 at MAC address on EN0, 10.0.1.2, you know, all of these different things. So basically this is the response that we are looking at here in this particular script. So now that we have this, right, this all comes in, but it comes in essentially as one long byte string. And so we have to turn this into something that is actually usable for us. So with that, we are then going to comment out the print again, and we're going to go through here and try to explain the rest of this script. So, right? So we saw that ugly response with all those next lines and all that. So what we're going to do is now we're going to say response equals string response. So when that comes in, it actually comes in as bytes. Even though it looks like text, it's bytes. Anyways, so we got to turn it into a string of data type. So we're going to take response, we're going to turn it into into a string. We're then going to split it. So split it is where you take a string and you split it into a list based off of certain values. So what we want to do is, so basically every line in that return, we want to turn into a value within a list index. So /n question mark, wherever there's a /n question mark, this will be a value for a list, and this will be a value for a list, and this will be a value for a list, so on and so forth. We have to put the additional / in front of the n as an escape. So if we just do n, it actually won't work right. So basically we have to escape the slash, so that slash is red. So /n question mark, we escape the /n question mark is actually red. So that's the escape there. Okay, so then we're going to do for line, right? So we have response. So we have all of these different values in response now. So for line in response. So for each line in that response now, IP underscore text is going to equal nothing. MAC address text is going to equal nothing. Vendor text is going to equal nothing. So this is important. So you clear out the variable values so you don't duplicate variable values as you go through. If this iteration of the list can't find a vendor, you don't want the previous vendor assigned to be printed out on the screen. So basically, we're clearing all of our variable values every time this loop goes through. We're then going to do try. So basically try, again, in the Python world, it's kind of like where you try to do something, try to accomplish this, and then if that doesn't work for some reason, do something else. We're simply going to do try, except this pass. If this doesn't work, we're just going to pass. The first thing that we're trying to do is we're going to try to find the IP address. So we're going to use the regular expression .search, right? So basically what this is going to do is regular expression search for this value within the line, right? So we go back here. So this is a line. So the first thing that we want to do is we want to pull out the IP address. So that's what we're going to be searching for. Can I increase the size anymore? Maybe make that a little bit easier, right? So basically we're trying to figure out what that IP address is. So with the search, this is where we get into regular expression. So R means raw, so raw string. Don't screw with it at all. Basically, the /D is for digits, so numbers. When we have the squiggly bracket, so we want somewhere between 1 to 3 digits with a period at the end. So it could be 10.192.1. Right? And then the squiggly here means 3 of these. So I want 1 to 3 digits with a period at the end, and I want that 3 times. Then, after that, we do /D, so digits. We want 1 to 3 digits for the final one with no period at the end. So what that means here is 1, so 1 to 3 digits with a period at the end, 3 times. 1 to 3 digits, 1 to 3 digits, 1 to 3 digits. And then for the final, we want 1 to 3 digits with no period at the end, 192.168.1.1. Right? That's what we're trying to pull out of here. And so this is where you get the regular expression. And again, if it seems too complicated, don't stress about it too much right now. And we're feeding it the line. IP underscore text equals IP.group. So what the group does is basically this just gets the IP address. So if you don't use this .group, you may get the entire line. That's a bit of a disaster. So .group, it just gets the IP address from the line. When we get the IP address, it's going to have little parentheses on either side. We don't want the parentheses on either side. So IP underscore text equals IP underscore text replace the left-hand parenthesis with nothing, and then replace the right-hand parenthesis with nothing, and then we just get a nice, beautiful IP address. If for some reason you can't get an IP address, then you're going to pass. So again, here with Python, this is a lot of times where you dump in some kind of like default value, something like that. Okay, then we're going to come down here. And so in that line, again, the line that we're dealing with, so we have IP address. So we want to print out the IP address on the screen. And then the most important thing, though, is that MAC address. So we're going to come down here. We're going to do try again. So MAC is going to equal regular expression search, raw number, right? So within these brackets, basically what this says is I want, if it's a digit between 0 to 9, if it is an uppercase character between uppercase A and uppercase F, or if it's a lowercase character between lowercase a and lowercase f. So basically, if it's any of those characters, and if it's either one or two of them. So when you have a MAC address, you may have a single digit, or you may have 2 digits. So basically 09AFAF, if it's one of them, that's okay. If it's 2 of them, that's okay. But that's all you want. And then you have this bracket. So it can then either be a colon or a minus sign, right? So depending on your operating system, it may spit out as colons in the middle, or it may spit out as the minus sign in the middle. And then we want 5 of those. We want 5 of those, right? So we take a look at this. 0 through 9, A through F, uppercase A through F. So 10, that's 2. C, that's 1. 6B is 1, or 2. D is 1. AC is 2. So this is the first one with a colon. This is the second one with a colon. This is the third one with a colon. Fourth one with a colon. Fifth one with a colon. And so at the end then, that ED, we want the same thing, 0 through 9, A through F, 1 or 2, but you'll notice there is no colon at the end because that's the end one, and we're going to feed it the line, right? Mac underscore text is going to be Mac group. So basically with this search, I just want to pull out that MAC address. That MAC address should be clean. So then I'm going to feed that MAC address to the REST API. Mac vendor lookup.com, API v2, that MAC text that we got using the regular expressions. From here, within this try, we're then going to try vendor equals request.get URL JSON. So basically, with this request.get, this URL that we created, bring it back as a JSON value, and then vendor underscore text equals vendor at 0 company. We do accept pass, and then from here we're going to print the record. So we're going to say record, then we're going to do tab, so /t is tab, the value for IP text, /t, the value for MAC text, /t, the value for vendor text. So it's going to be the value, tab, right? And then we're going to sleep for 2 seconds so that we don't hammer the rate limit. When I then run this, hopefully after all this explaining, it doesn't fail on me here. Basically what we're going to see is, again, record 10.0.1.1 at this MAC address is Apple. 10.0.1.2 at this MAC address is HP. .3, this MAC address is Apple. 13, this MAC address is Raspberry Pi. 35, this MAC address is Raspberry Pi. And you will notice, right, there's an IP address, IP 1.4 and 1.34. Again, within their system, they don't have a value in their database. So this is something that you might, again, have to consider with the whole system that you're going to be setting up. Again, with this, I swear to you, regex is just one of the pain in the butts. What I'll tell you about regex is really nice is it's a pain in the butt to do it the first time, but then once it's in your code, you really don't have to touch it again. So I know trying to figure out some of this can be a pain in the butt, but just understand this is something called regex. This is called a regular expression. We will have more classes on it. We are going to be using it a lot because, again, you need it to be able to parse values out of results that you're getting. But basically, again, this regex up here, this is how you're able to pull an IP address out of the line. This regex down here is how you're able to pull a MAC address. And then once you're able to pull that MAC address, you're able to feed that MAC address to that REST API. And now, so for our final script here, again, when we're pulling from that ARP table, that will only show us any computer that our computer has already communicated with, again, for whatever reason. If a computer is new to the network or it just got rebooted or has a new IP address recently, for some reason it might not show up in that ARP table. So basically with the script, this allows us to simply ping an IP address, get the MAC address from that device that we just pinged, and then again be able to resolve the vendor, right? So if we click on the go thing here, again, it's now going to ask us for an IP address, gives us a little interactivity. So 10.0.1.1, let's say, it's now going to ping that IP address. It's going to show us that, so we know what's going on. Then it's going to give us the MAC address, and then it's going to give us the vendor, right? So this is more of just a single thing that we're going to be doing. When we take a look at this, we're going to import subprocess. So again, subprocess is what allows us to run a command against the operating system and get the result back. Import requests, and oh boy, import regular expressions, import RE. MAC underscore text equals not found. Vendor underscore text equals not found. So we're going to create the variables for MAC text and vendor text, and we're going to say not found here. And so this is so if we go and we ping and we don't get a value back, it'll say nothing was found, right? So host equals input IP address. So the input function is what allows us to ask for an input. So when I do this, right, that IP address here, that is that IP address. So host is going to equal whatever you input there, right? Then we're going to print out IP address and whatever that host is. So again, that's a good troubleshooting routine, especially when you're new. Make sure you didn't fat finger something. Then down here, what we're going to do is we're going to do try. So again, try to do something. Command underscore ping equals fstring ping space -C1 and whatever that IP address value is. Again, do remember this is the Linux world or the Mac world. I'm using a Mac for this. If you do ping and you don't do a count of something, it will just keep going and going and going and going forever. So basically with this, we just simply want to do a count of 1. And so what this is going to do is this is going to be the communication with that IP address, with that network device that we don't see in our ARP table. And once we do that communication, we'll have the MAC address, right? Address Resolution Protocol resolves MAC addresses or IP addresses. So if we haven't communicated with a computer in the past, this ping will be a communication so that we can get the MAC address, right? Response underscore ping equals subprocess, check output, command ping, shell equals true, right? So basically with this, all I'm doing here is I'm actually just running the ping command. I'm just running the ping command. I actually don't care about response underscore ping. I don't care about this value. I have it here for troubleshooting purposes to make sure that I'm actually getting a response. But otherwise, just simply assigning this value here is what does the ping. When I do the ping, that will then get me the MAC address. So command is going to equal, and so what this is fstring arp space -a, the line thing, and then we're going to use something called grep. So what grep does is it finds any line within like an output from a command that has whatever value that you're looking for, right? So this is a big thing, especially in the Linux world, is you may run a command and then the output from that command is just like 5 pages long. And you're like, I don't care. I just want to know specific things. I just want to know the IP address. Or I just want to know the MAC address. Or I just want to know something. And so you can actually run a command, pipe it through grep, and then grep will only give you the specific lines that you care about. So we do grep with -w, or so with W, what this is going to do is it's only going to give us this identical result, right? So this host, so 10.0.1.1, I'm going to do arp A, and then I'm going to grep, and then I only want the line that's identical to 10.0.1.1, right? So since I pinged this host. As soon as I ping that host, I now have a MAC address in my ARP table. I'm then now going to query my ARP table, and I only want the result for whatever is the same as that IP address. Response underscore arp is going to subprocess check output that command shell equals true. Response underscore arp equals string response arp, because again, remember this comes back as a byte value, so we need to turn it into a string. We then are going to have that one line, that one string, and we need to search for the MAC address. So MAC equals RE, regular expression, dot search, and this whole 09AF, AF, 1 or 2, colon or hyphen, 5 of those, 09AF, AF, 1 or 2, nothing else, right? So 5 of these, 1 of those is what a MAC address looks like, and we're feeding in the ARP response. MAC underscore text equals MAC.group. So this variable value, we want to use .group, so this will only pull out the MAC address. Once we've pulled out only the MAC address for MAC text, we're going to feed it to this REST API. Then vendor is going to equal request.getURL.json. So this URL, we're going to try to get the value back as JSON. The vendor underscore text is going to be vendor 0 company, as we talked about before. Accept, pass, accept, pass, accept, pass. And then we're going to print out MAC address is the MAC text, and vendor is the vendor text. So again, so if I run this, and 10.0 to 1. What did I say? 35 I think it was. So if I do this, I think this will give us the Raspberry Pi. Hope so. There we go. That's the IP address that we pinged, the MAC address for that IP address, and the vendor, right? So we can ping a specific device. So again, if you have maybe a printer on the network, something like that, this might be useful. The other thing we can do here, just to show you if nothing is found, so let's say 10.0.1, So we try to ping that IP address, and basically that's going to fail out. So when that fails out, it's going to take a second to fail out. Do remember whenever you create these programs that you realize you have that fail out time period. So MAC address is not found for 10.0.1.50, and vendor is not found for 10.0.1.50 because obviously we did not have a MAC address there. And so basically those are the 3 scripts for today. The first script, we just feed it the MAC address. The second script, we feed it the ARP table and then pull out the MAC addresses. And then the third script is where we ping a particular device and then find out what the MAC address and what the vendor is for that particular IP address. So there you go. There is the class for today. Now, if you're not a complete noob, you've actually been around the block a couple of times, you may be asking, why didn't we just use Nmap? And to be clear, if we were in the real world, I would probably just use Nmap, right? So Nmap, if you don't know, is an absolutely great utility for scanning a network, finding all the devices on a network, finding the ports that are open on those devices, again, finding things like vendors, finding a lot of information. So basically, to be clear, what I showed you today can probably be more effectively be done with Nmap. But what I want you to be thinking about, especially if you're new in the technology world, is what I want you to be thinking about is how you can go out, you can try to find problems to solve, again, with technology, try to find things like these different REST APIs, and then try to be able to build your own little widgets, your own little applications from the ground up. Again, everything that I showed you today, literally, I was sitting there thinking about this whole MAC address thing. I was like, I wonder if there's a REST API for MAC addresses. And then I sat there and it took about a day to write up all this code because I think it's an interesting learning lesson for you for, again, understanding how MAC addresses work in the computer, the networking world, understanding a little bit more about how regex works, again, focusing more on using these REST APIs to be able to make requests based off of variable values, that type of thing. And so with this, you're able to build something yourself in order to try to solve a problem. Is there a better product out there? Yeah, of course there probably is, but this is a way to get you thinking about how to solve problems, right? Again, in a relatively simple format when I'm trying to do these classes for you. Again, MAC addresses are a very interesting thing. You get a lot of tinfoil hat people nowadays. You get a lot of these anti-authoritarian people nowadays talking about the new world order, and they're like, yeah, they're trying to create a fingerprint for everybody's computer. And again, one of the reasons I laugh about this kind of stuff is like, buckos, that's existed since Ethernet existed. MAC addresses are a core component to the Ethernet standard. Whenever the hell Ethernet came out, 1970, 1960, 1870, I don't know, but MAC addresses were part of it. That's part of the damn standard. And so again, it's an important thing to be thinking about to understand how this technology works. And again, especially in the modern world where people start going, to know what you should be worried about. What is actually a new thing? Again, with these MAC addresses, now to be clear, with MAC addresses, a web app, right? So I'm going to a website here. So the website should not be able to access my MAC address. And so theoretically, a website, unless I feed it my MAC address, it should be safe. But if you install an application onto your computer it is very trivial for that application to pull your MAC address and send it up somewhere. If you install something onto your Linux computer, your Mac computer, your Windows computer, pulling your MAC address is a trivial task, and they can just ship that thing up onto the internet into some database server somewhere, and then they can track you all over the place relatively simply because, again, this is a globally unique identifier. So if you have an app on your computer and you log in from work, it'll know where your work is. If you log in from the hotel, it'll know where your hotel is. If you log in from somewhere else, it'll know where that is, right? And they're able to track that. The other thing to be thinking about from a security standpoint is we are using a REST API call here. So you got something to consider. Whenever you use an API, right? Things go back and forth. It's not that you simply get stuff, but you also have to give them something. And when you give them something, you have no idea what the hell they're logging. So something to think about, like with this, oh, this is kind of cool. I want to build this into some kind of network scanner that I'm creating for our managed service provider company, right? So imagine you use this REST API, you create some kind of scanning application for all of your field techs. All of your field techs then go into the field. They hit run and just realize every time you make a request to macvendorlookup.com, they know what your external IP address is, so they know your location, and they can start associating some kind of like facility location with all of the devices within that facility location. And, again, as I've said many times before, if I was running the NSA, I wouldn't be worried about $8 billion data centers. I'd be building a whole bunch of quote unquote free APIs with some massive, massive, massive logging behind them. So again, one of those things that you have to consider for educational environments. Again, who the hell cares? I'm not worried about either the NSA or the KGB understanding what my network looks like here at Silicon Dojo. But again, if you're a decision maker, right, if this is going into a production environment, it is something that you have to consider. So anyways, there you go. I hope the regex didn't melt too much of your brain. If it did, that's okay. It melts everybody's brain. Again, one of those things you just got to play with a lot. The rest of it, using the REST API, I think is relatively easy. So as always, I enjoy teaching this particular class and look forward to seeing you on the next one.